This is a maths revision video by Andrew Brodie from AB Education. Understanding Pythagoras Theorem. Pythagoras Theorem works with right-angled triangles. Here's a right-angled triangle where the base of it is 4 centimeters long and its height is 3 centimeters. The longest side of a right-angled triangle is opposite the right angle and has a special name, the hypotenuse. What Pythagoras theorem states is that a square drawn on the hypotenuse has the same area as the total of the squares drawn on the other two sides. Looking at the red square, you can see that the area of the square drawn on that side is 16 square centimeters. The area of the square drawn on the yellow side is 9 square centimeters. Now watch as we find the area of the square on the hypotenuse. The area of the square on the hypotenuse is 25 square centimeters, which is the sum of the other two sides. So the length of the hypotenuse must be 5 centimeters, which is the square root of 25, because 5 times 5 is 25. Pythagoras theorem states that the area of the square on the hypotenuse is equal to the sum of the squares on the other two sides. On this right-angled triangle, the hypotenuse is labelled with a capital H, and the two shorter sides are labelled A and B. The short, simple way of stating Pythagoras theorem is h squared equals a squared plus b squared. This is the bit you need to remember. Look at this example. We can see that we've got a right-angled triangle, so we can use Pythagoras. We can see that one of the short sides is 5 centimeters long, and the other is 7 centimeters. We know that h squared equals a squared plus b squared, so that's 5 squared plus 7 squared. 5 squared is 25, and 7 squared is 49. Add those together to get 74, so we know that the hypotenuse squared is 74. To find the length of the hypotenuse, we need to find the square root of 74. On the calculator, this comes out as 8.60232527. To one decimal place, this is 8.6 centimeters. So the length of the hypotenuse is 8.6 centimeters to one decimal place.